Secure network devices and protocols. When we talk about secure devices, that will most often be a firewall. Just like the routers and switches, it has a specific purpose, something it's built for and something it does very well. And there are multiple different types of firewalls we use in our environments. Some are more legacy and some we use now. We use firewalls as a barrier between our trusted secure internal network and the outside network, like the internet. And just as there are multiple different types of firewalls, there are also multiple different configurations we can use them in to get the security posture we need in our organization. First generation firewalls were packet filtering firewalls. They would work on the OSI layer 1 to 3. And as the name indicates, they filter packets. If a certain packet doesn't fit the filtering rules we set up on the first generation firewall, the firewall will either drop the packet, reject it, or send an error response to the source IP. But any packet matching one of the permits in our firewall rule will be allowed to pass. And the rules are checked in the order they are in the access list. On the graphics over here on the right, I have a very simple access list for Generation 1 firewall. Anything with a source and destination address 100.1.1.0/24 is permitted. That's traffic between hosts on our internal network. That's behind our firewall. We also have a permit statement for anything from 100.1.1.0/24 to any destination, meaning we can go to the internet. But then we have a deny from any source destination to anything in our internal network is denied, meaning technically we can go to the internet, we just won't get traffic back. And then at the end of any access list, there's an implicit any deny, meaning anything we didn't specify in the access list as a permit that gets denied. So if the attacker with a 200.2.1.55 address tries to send anything into our organization, that traffic will get denied. Even if we had an IP within our organization, was not specified in a 100.1.1.0 subnet, that would also get dropped. So Generation 1 firewalls are very, very simple, which at the time when they were designed was a step forward, but not something we can or should use today. The next natural development was second generation firewalls, or stateful filtering firewalls. They work on the OSI layer 1 through 4. They also inspect all the packets that passes through the firewall. They then determine is it part of an existing connection or a new connection. And we still use not super complex rules, but they are way more granular than a first generation firewall. If you look at the rules over here on the right, you can see the first rule states any internal IP with any port is allowed to access any IP on the outside at port 443, meaning we can access secure websites. And then the second statement, deny any IP, any port, going to any port, and any IP. So anything really that's not specified in the first rule is denied. So in my example here, we have an internal workstation with the IP 100.1.1.1 going to an external web server, and since it's going on port 443 or HTTPS, the connection is allowed. Once the connection is established, the firewall writes a state table entry showing that socket pair or those pairs of IPs and ports are allowed to communicate with each other. So when the web server sends traffic back, the firewall checks the state table, it sees it has an entry, and it allows the traffic back onto our network. These are still the static rules we used before, but we include a state of a connection to allow or deny traffic back into our network. And then obviously the attackers found way to compromise our second generation firewalls. If they send thousands and thousands of fake connection packets, they can, if our firewall is not configured right, overwhelm the firewall by filling the connection state memory and then crashing the firewall. And firewalls should always fail closed. Whereas any physical security we have on our facility, that we always want to fail open because people need to exit. If a firewall failed open, then there will be complete free access to our network. So firewalls failed closed. A proxy server can also at times act as a perimeter defense for us. We send our request to the proxy server contacts the outside, gets a reply back, and we get the data from the proxy server. And then obviously the proxy server would be very hardened. We can set certain traffic up that's only allowed to pass, and then block everything else. And we can also set them up on our internal networks if we have parts of the network we want to segment off. Not super commonly used anymore. We normally would do that with VLAN segmentation, but I am going to assume there's still a fair bit of them out there being used because, well, it's just easier leaving the old stuff in place instead of having to design and pay for something new. And where the first and second generation firewalls are not super efficient today because we are encrypting our traffic. Remember, encryption happens on layer 6. which means that in most cases, those firewalls are going to see encrypted packets. They have no clue of what's in the payload. Which brings us to third generation firewalls, application layer firewalls. Since the application layer, they are an OSI layer 7. On top of seeing the full unencrypted packet, layer 7 is, as you know, much smarter. It can understand the applications and the protocols we use. And since they're much smarter and they have the unencrypted data, a lot of the attacks that can get by a first or second generation firewall will be caught by a third generation. We also use both network firewalls and host-based firewalls. And we use them together because they are for different purposes and they can detect different things. A network-based firewall, we can use at the edge of one or more of our networks to kind of get the big picture. It can correlate all the stuff that's happening, and it doesn't just see one little application or one workstation or server. And they can either be on regular hardware, just an application running on top of that, but in most cases we would want hardware that's built exactly for that one purpose, because it's just better at the job. A host-based firewall is, well, on the host. It sees that one specific host, all the traffic in and out of the networking card, it can monitor and act on. When I hear the word bastion host, I think like castle, bastion, well fortified. And that is what it is. It's a host designed, built, and hardened to withstand attacks much more than normal systems. They normally only house one application, and everything we do not need has been removed or shut down. And we would normally use them either in our DMZ, the demilitarized zone, or outside of our firewall. That could be a web server or something that we need the outside to be able to access, but we obviously also need to make it as secure as possible. A dual-homed host is kind of the predecessor to firewalls. It basically has two network interfaces, or at least two, one facing inwards to the trusted secure network, and one facing outwards to the untrusted internet. It does not route traffic. All it does is allow someone from the inside to log into the dual-home host, and then from there, they can access the internet. Since it was way more hardened than anything we would have on the internal network, it was a slightly more secure way of doing it, but not used anymore. Shouldn't be used anymore. Use firewalls. Screened host architecture is also something we should not use anymore, and I hope you don't. Again, something that was mostly used before we started using firewalls, or at least before they came into a price range that were reasonable for most people. It was just using a screening router with a lot of access lists on it, allowing or denying traffic from the outside and from the inside out. It is similar to dual home host, but here we use the screening router for the traffic filtering. And it does not use defense in depth, meaning a failure on the bastion host puts our entire internal network at risk. Which then brings us to the next natural progression, screen subnet architecture. With this, we combine the dual homed and the screened host network firewall or router. You can see over here on the drawing, traffic coming from the internet hits the external screening router or firewall. Early on it was still routers, later on it became firewalls. Then we have a DMZ, a demilitarized zone, where we would have our web servers or anything that someone from the outside would need to access. And then we have another firewall or screening router. Once you get past that, you're in our internal network. And obviously the internal router or firewall would be a lot more restrictive in what it allows from the outside. If the DMZ has our web servers, we want people to be able to get to those, but they in no way should be able to get to our internal network. And good firewall design, we would always want to use different types of firewalls, in this case for the internal and external, because what if that firewall we have has a vulnerability? If we use the same firewalls both for internal and external, they will both have it. We can much easier be compromised. If for the external one we use Cisco and for the internal one we use Juniper, it's much less likely that both of them is going to have the same vulnerability. Let's look a little more at DMZs. A normal DMZ would use the two firewalls we looked at in the screen subnet, but it could also be a three-legged DMZ with only one firewall. One connection to the internet, one connection to the DMZ where the hardened host lives, and then one connection to our internal network. It is more secure, but again it has that single point of failure. What we really want in our firewall design is a full mesh like the picture at the bottom. We have two internet-facing firewalls. That's our first firewall pair. Any of those four firewalls are connected to the other three, which means we're not going to have a single point of failure. If the top right firewall fails, well, then it'll just use the bottom right one. And here, of course, we'd use the two different brands of firewalls to ensure all of them doesn't have the same vulnerability. I haven't seen anywhere where they use 4 different types of firewalls. I think at that point it just gets too complex, and when you have a firewall pair, in most cases you want them to be almost completely identical. So yeah, don't use 4 different types. And we already covered how they need to feel closed. Again, top right firewall gets flooded, it crashes, it doesn't just open up for everything, it closed shut. Then all internal traffic going into our network will go through the bottom right firewall.